Digitizing the dental cast. After having a traditional impression and prepared the dental cast, the scan post and the scan body are placed into the analog in order to capture the implant position. Now we start the software. Here we use Sirona and select, step by step, all the information the software requires for the planning and production of a restoration. First of all, we have to determine the restoration type. In this case, crown, implant superstructure, and we have to decide if we want to do it in biogeneric individual and design it ourselves, or if we want to copy a specific shape. After having selected implant superstructure and biogeneric individual, we need to select the tooth we want to restore. After the tooth is chosen, we select the implant type and the interface, in this case tie-based Sirona and FX 3.8, the corresponding interface for all Leone implants. The software also wants to know if we will use for the scan process a tie base or a scan post in order to calculate the right height and proportions. Then we will have to specify the milling device, the material, zirconia oxide or lithium disilicate. Here we will use lithium disilicate, for example, IPS Emax CAD. On the right side there is an overview window where we can check all our settings. If everything is correct, we can go ahead by clicking on the double arrow, and the program switches over to the scan phase. The acquisition procedure starts. The pink gingiva should have been powdered with titanium oxide to improve the scan quality. By clicking on the black area, we can improve the measuring accuracy. Afterwards, we can duplicate the scan in another file, the gingival mask. The gingival mask will help us during the planning of the emergence profile. In the next step, the software will edit the models, the digital dental casts. We have to check them and correct any defects. Examine the opposing jaw, the gingival mask, which is simply a duplicate of the model. It is not necessary to always scan the whole jaw. We can simply create a scan of the area around the implant by acquiring two neighboring teeth on the left and two on the right side. Here we are checking the buccal bite registration in order to examine the relationships, proportions, and the contact points. We align the two jaw models within the schematic arches and align the horizontal and vertical guiding lines in order to help the software determine the planning of the teeth. We move the blue balls so that the line matches the main jaw line and position the blue tooth number 9 in the center of tooth number 9. We cut the area around the implant and show the software the position of the scan body head by double-clicking on its top. In the next step, we check the restoration axis of the tooth and adjust it if necessary by moving it. The user will be warned by a change in color to red when he exceeds specified safety limits, such as wall thickness limitations. In the following steps, we can adjust the parameters. In this case, the most important one is the degree of compression of the crown or pressure exerted on the gingiva by the crown. We are designing more passive pressure or more compressive pressure. All other parameters relate to wall thickness limitations, and once we've made these parameter settings, we normally will not change them. As soon as we've defined the shape, the software adapts the crown to the implant. Now we have to complete and to optimize the shape with the tools the software provides. In shaping, we can, for example, apply or remove material, or we can smooth the surface locally in order to design a tooth which is as similar as possible to the adjacent tooth. Once finished, we can switch to the milling preview. Here we can select the block size according to the size of the restoration. In this case, we have to choose a higher block. After having examined all aspects, we can start the milling process. Up to this point, we've seen the planning of a monolithic crown. Alternatively, it is possible to plan a hybrid abutment, for example, a customized abutment part to be bonded to the tie base abutment and a separate crown to be cemented to it. This procedure is the most appropriate solution in a case of a strongly angled abutment because it allows one to apply the appropriate tapping force on the abutment to fully seat it and then to cement the final restoration to it intraorally. To do so, we simply have to go to the administration phase where the software gives us the option to change our settings and select the multi-layer option. When clicking on the multi-layer option, the administration adds an additional request regarding the veneering structure material. We select the veneering material, in this case, lithium disilicate. We choose also the material for the abutment, which in this case is zirconium oxide. Now the software has all the necessary information in order to split the project we already finished. To do so, we will use the split function. We select the split option through the associated button and click on the Apply button. The software will split our monolithic crown and ask us where to split it. The software shows us the underlying abutment and in transparency the crown we've designed. Now we can change the shape according to our needs. Once the planning is finished, we will have two milling processes with two different blocks. We switch to the milling preview and select the block sizes. After having examined all aspects, we can start the milling process. The milling device will produce first the abutment and then the crown.